Hello class, welcome to this video on the Chapter 9 review. So we're going to review these questions. Take good notes, submit this and to Canvas, and you can go ahead and do the test review, the retake after this, and you should be well prepared for the test, okay? All right, so solve the right triangle, round side and angle measures to the nearest tenth. Okay, so we have a right triangle here. We want to solve it. And solving it means that you want to get all the sides, all angles and all sides. Now they already told you this is 90 degrees, so you don't have to figure that out, but you do have to figure out these two angles, that one and this one. Okay, and let's call this X here. So this is going to give us X, which is equal to EF, okay? So remember, if it's a right triangle, we can always use Pythagorean theorem to get that. So we'll do that in a second. Now first, let's try to figure out angle D. So let's figure out what angle D is. Now remember, in order to figure out angle D, you would need to know your trig, so SOHCAHTOA. SOHCAHTOA. All right, so this stands for, S stands for sine, C stands for cosine, T stands for tangent. O stands for opposite, H stands for hypotenuse, and A stands for adjacent, okay? So S stands for sine, C stands for cosine, T stands for tangent, O stands for opposite, A stands for adjacent, and H stands for opposite. Okay, so for example, S is sine, so sine of angle, in this case, sine of an angle, you have to provide an angle, is equal to opposite over hypotenuse, okay? Is equal to opposite over hypotenuse. So O over H. So there's the in SOHCAHTOA. And then you got C for cosine. Cosine of angle, you have to provide an angle, is equal to AH. So A over H, okay? Adjacent over hypotenuse, All right, and then you got tangent of angle. You have to provide an angle, is opposite over adjacent. So you got tangent TOA. All right, so that's how you use SOHCAHTOA. That's how you memorize or know what sine, cosine, and tangent are for the fractions, okay? Now, here, if I do sine of angle D, I'm just going to give you a few examples. So sine of angle D, I'm going to say sine of measure of angle D, cosine of measure of angle D, and tangent of measure of angle D. This is just talking about angle D, okay? Now, if I use angle D, then this is my angle, and then this is going to be opposite. That's opposite. This is going to be adjacent. Adjacent means it's next to the angle. And this is going to be hypotenuse. Hypotenuse is the longest side of the triangle. The longest side of the triangle is 6. Okay, you have to know how to identify what opposite, adjacent, and hypotenuse are. So in this example, sine of measure of angle D is equal to opposite, which is X, over hypotenuse, which is 6. All right. And then cosine of measure of angle D is 4, which is adjacent, over hypotenuse, which is 6. And then tangent of angle D is opposite over adjacent, so X over 4. Now, of these three, which one is the best one? Well, the best one is this one because we know both sides, 4 and 6. And the other two, we don't know the one side, X, right? So it's best to use this equation. So we're going to go ahead and use that because that's going to give us one unknown, the one unknown being the angle. Okay? All right, so let's just officially solve it. I'm just teaching you the lesson, teaching you a mini lesson, but now let's apply it. So we got cosine of the measure of angle D is equal to adjacent over hypotenuse, which is 4 over 6. Now we want to solve for the measure of angle D. So if I want to solve for that, I got to get rid of the cosine. The only way to get rid of cosine is to do something called the cosine inverse. So cosine inverse, like that. All right, so that's the only thing that's going to get rid of the cosine. And so these cancel. Now, whatever I do on one side, I have to do on the other side. Okay, so you got cosine inverse, and I usually put this in parentheses, and then cosine inverse of this. All right, so notice that the cosine and the cosine inverse cancel, leaving us with that. So we get the measure of angle D, which is what we're looking for here, is the cosine inverse of 4/6. And you can do this on any scientific calculator, and you can use it on Desmos, which I'll show you on Desmos. All right, so we're going to show you on here. This is the calculator that you have access to, right? And when you do the tests and stuff, you know, you can also use a graphing calculator and all that, or scientific calculator. But you see the cosine, and tangent. That's available on any scientific calculator. But you want to do the cosine inverse. So we want to do function, and then we're going to do sine inverse. Okay, so you got sine inverse, but we want to do cosine inverse. So we don't want to do sine inverse. So cosine inverse of, then we got 4 divided by 6. 4/6. You can also do fractions and stuff, but remember 4/6 means 4 divided by 6. Okay, you got to understand that fraction means division. Got to understand that. All right, and then we got 48.189. So about 48 degrees approximately. 48.2 degrees. All right, now they did say to the nearest tenth, so we're going to do 48.2 degrees, okay? All right, so it takes care of that. So now let's do the measure of angle E. So now we know that this is now 48.2 degrees. Now that's 48.2 degrees, and this is 90. Then we can figure out what E is. The angles in a triangle add up to 180 degrees. So to find angle E, we would have to simply just do 180 minus the other two angles. 90 minus 48.2, because they have to add up to 180. So I got to subtract those from 180 to get the other one. All right, so then I get that. And so that would be, and I'll put that as an answer here, 31.8 degrees. Oh wait, that should be, sorry about that. It should be 41.8 degrees. All right, so there you go. All right, so now let's figure out what x is. Now, remember we said we have a right triangle here, so we can use Pythagorean theorem. All right, so let's do that. Pythagorean theorem. So again, we have this right triangle, which is x, and this is 4, and this is 6. So we're going to use the Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. All right, this works for right triangles only. So this is like my a, this is my b, this is my c. C is always my longest side. So here we got x squared plus 4 squared equals 6 squared. So we got x squared, 4 times 4 is 16, 6 times 6 is 36. Now I'm going to subtract 16 on both sides. We get x to the second power equals 20. And I'm going to take the square root of both sides. That's the only thing that can get rid of the squared, okay? So that cancels. So we get x is equal to the square root of 20. All right, and remember, we're going to show you how to break this radical apart, okay? So you can show your work. So remember, 20 breaks into 4 times 5, and then 4 is 2 times 2. And 5, you can't really do anything with 5, so we can leave it. And then we're done with the 2's. You can't do anything else. Now, if you have any pairs, you need to kick them out. So we have a pair here. So we're going to kick that out. We're going to give it the boot. All right, so this pair that I kicked out will go on the outside of the radical. So you have a 2 on the outside and square root, and then you have a 5 on the inside. So there you go, 2 square root of 5. Now, you're going to do this on the calculator to see what this is as a decimal. You can do square root of 20 or 2 square root of 5. Even though they want this as a decimal, they may ask for this answer, and this is why I do both ways. Okay, so you may want to write it this way if they ask for it. However, in this problem, they want the decimal, so we don't have to write it as 2 square root of 5, but just in case they ask you that on the EOC or on another test. All right, so square root of 20. Okay, so we're back on the Desmos calculator, and we're going to do square root of 20. So let's delete that. So we got square root of 20, which is 4.47. Now, if I also did 2 square root of 5, notice that I get the same answer. And that's not a surprise because we figured out that those two are identical, remember? So 4.47 is my solution, 4.47. All right, so now we know that it's 4.47, but remember they want us to round to the nearest tenth, right? So we're going to round it to 4.5. All right, there you go. That's my third solution here. Okay, so that's how you solve the right triangle. Now, which of the following could be the measures of the sides of a right triangle? Okay, so now remember, for it to be a right triangle, you have to be able to use Pythagorean theorem, right? So if a squared plus b squared equals c squared, if that's true, then you can say that that's a right angle, okay? But if it's not true, if this is true, I'm going to say that it's a right triangle. Now, if a squared plus b squared equals c is less than c squared, then we would say that that's an obtuse triangle. If a squared plus b squared is greater than c squared, then it's an acute triangle. Okay, so know those three cases, but here in this example, we only want to look at the first case. Is it a right triangle, yes or no? Okay. All right, so let's go ahead and plug this in. So remember that C is the longest side. So this is C, this is C, this is C, and this is C. If it's not in order, make sure you pick the biggest one. The biggest one has to be C. But here it's in order, so it's easy to tell. All right, so let's do the first one. A squared plus B squared equals C squared. Now, that's option A. Now, the square and the square root cancel. The square and the square root cancel. The square and the square root cancel. They're opposites. So we get 3 plus 4 and 5. Now 3 plus 4 is not equal to 5, so it's not a right triangle. Okay, so it cannot be that one. So let's check the other one. So we got square root of 5 squared plus square root of 12 squared, square root of 17 squared. So remember, these cancel, the square root and the square cancel. So we get 5 plus 12. That is equal to 17. So that's a right triangle, right? Okay, so that looks good, but we want to see if there's any other ones, which of the following could be. So let's check the other ones. 7 squared plus 15 squared equals 16 squared. So 7 squared plus 15 squared equals 16 squared. All right, 7 times 7 is 49, 15 times 15 is 225, 16 times 16 is 256. Now, you don't have to memorize that, you just do it on the calculator, right? So you have this, you add these up together on your calculator, and then you get 274, which is not equal to 256, and so it cannot be a right triangle, so no, it's not a right triangle. And then we check the last one. So 9 squared plus 16 squared equals 25 squared. So 9 times 9 is 81. 16 times 16 is 256. And we got 25 times 25 is 625. And that's definitely not equal to that. So we're not going to choose that. All right, so it's got to be B. All right, so look at the next one. The diagonal of a square is 12 inches long. What is the length in inches of each side of the square? Write the answer in simplified radical form. All right, so what is the length in inches of each side of the square? Write the answer in simplified radical form. Okay, so we got the diagonal of a square. So we got a square, and we know that the sides of a square are the same, right? And it says the diagonal of the square, and we know that the angles in a square are right angles. So we have that. And so we got a diagonal is 12 inches long. So we got 12 inches. And what is the length in inches of each side of the square? So we're going to call this A, whatever you want to call it. I don't know. Let's just call it S for side, whatever you want to call it, of each side. So, but we know the sides have to be the same. And so if this were normally a right angle there, then this diagonal is going to cut it in half. So that means that these two angles are the same. So they're both 45 degrees, right? Because 45, 45 makes a 90 here. And then this and this has to be 45 as well. So we have a 45, 45, 90 right triangle. So we have a special right triangle. Okay, so this is a special right triangle, which is a 45, 45, 90. There are two special right triangles. So let's look at the formula sheet here. We got two special right triangles, right? Number one, number two. So I would draw these, but this is in your formula sheet. So we got 45, 45, 90. So we're going to draw it just like that. But we know that we have x square root of 2. So we're going to use this, but we're going to make it look like the picture on the left, okay? So so I'll just leave it like that. So if we got 45, 45, x square root of 2, okay? But we're going to make it look like this, okay? So that means it's facing like this, okay? So we got 45, 45, 90, and we got x square root of 2. You can see that. And so now you can see that this matches up with that, right? And we can see that this matches up with that. Okay, so that means s is equal to x, and then x squared root of 2 is equal to 12. So let's do that part first. 12 is equal to x square root of 2. Well, then how do I solve that? Well, I got to get rid of the square root of 2 on both sides, so I'm going to do this. So I'm going to divide that off, so it cancels. And so I got x is equal to 12 over square root of 2. And remember, we don't like square roots on the bottom, so we got to get rid of it. So I'm going to multiply by square root of 2, top and bottom. Every time you have a square root on the bottom, just multiply the top and bottom by that same square root. And so here I have x equals 12 square root of 2. Just put the top together. And then at the bottom is square root of 2 times square root of 2, which is the square root of 4, right? Square root of 2 times square root of 2 is square root of 4. But the square root of 4 is 2. Okay, so I'm going to plug that in here. So I'm going to say that this is equal to square root of 4, which is equal to 2. So let me plug that down here. And then now we have that 12 divided by 2 is 6. So we have 6 square root of 2. That's my x. So we know that this is 6 square root 2. All right. So now that we have that, well then if that's 6 square root of 2, then this is 6 square root of 2, right? Because 6 is equal to s is equal to x. And so there you go. So now we got that s, or the side of the square, is 6 square root of 2 inches. All right, so it's got to be A. All right, so next one, it says, what are the values of x and y? Now this is 30 degrees, which means this has to be 60. So we're dealing with a 30, 60, 90 right triangle. So let us look at the formula sheet, and that is one of our special right triangles. We got 30, 60, and 90. All right, so 30, 60, 90. That means we're going to be using this one. So remember, the 30 degrees next to that is the square root of 3. Next to that, between the 30 and the 90 degree angle is x square root of 3. Between the 90 and the 60 is x, and between the 30 and the 60 is 2x. Okay, so we're gonna remember this, and we're gonna draw the triangle so it looks like the triangle in the problem. Okay. So notice that it's tilted the other way. So we want to draw it just like that. We want to draw it just like that so that we can correctly compare them. All right, so we got 30 degrees, we got 60, 90. Now it says between the 30 and the 90, between the 30 and the 90 is x squared root of 3. Okay, so we got to do that here. Between the 60 and the 90 is x. Between the 30 and the 60 is 2x. All right, now that we got that, we know that, and since this is x, we don't want to use x twice. So I'm going to change this x to a different variable just so that I don't get confused. okay, with the x that is in this problem, because I do not want to get confused by those two. So I'm going to call it a. All right, so now let's compare these. X is equal to a. Let me do that in one color, blue. X is equal to a squared root of 3, sorry. So let me write that out. So x is equal to a square root of 3. We got y is equal to 2a. And we'll just do this in purple. Square root of 15 is equal to a. So we know a is equal to the square root of 15. Well, then that means we can plug it into there. So y is equal to 2 square root of 15. And we can also plug this into here as well. And so we get x is equal to square root of 15 times square root of 3. All right, so we got y. So y is equal to 2 square root of 15. Now let's get x. Now x is square root of 15 times square root of 3, so we need to simplify this. So let's break this up. We have 15 times, we have 15 times 3 is 45. Now we want to simplify this because we want to simplify the radical. Now 45 is 5 times 9, and 9 is 3 times 3. And we can't do anything else there. But notice we got a pair of 3's. So we can give that the boot. Okay, so 3 is going to go on the outside of the radical. And let me do a different color for that. Let's do green. So 3 is going to go on the outside. And 5 is going to stay on the inside. Or wrong color there. Okay. So we got 3 on the outside. And 5 on the inside. All right, so it's equal to 3 square root of 5 for x. All right, so we got x and we got y. So x is 3 square root of 5 and y is 2 square root of 15. So the answer is B. All right, so now it says this one, use the figure to the right, which trig ratios have a value of 21 over 29? So remember, good old SOHCAHTOA, right? SOHCAHTOA, we're talking about trig ratios. So which trig ratios have a value of 21 over 9? So let's look at cosine of A. So cosine of A is equal to, remember, cosine is adjacent over hypotenuse, right? So if I look at, if this is A, right? This is angle A. What is adjacent to that? Well, we know that this has to be opposite, right? Because that's opposite or across from the angle. And we know that this is the longest side, H. And so therefore, this has to be adjacent, which is next to that. Okay, this is A for adjacent, by the way, not for angle A. I don't want you to get confused by that. This is for adjacent, which is what that stands for, okay? And this stands for adjacent here, for the A there. So cosine is adjacent over hypotenuse. So that means it's 20 over 29. Now that is not equal to that, right? So we're not going to choose that. So we're not going to choose that at all. So we're not going to choose that at all. So I'm going to cross that out. Now let's look at cosine of B. Or let's do the sine, or let's do the ones with A because we just did angle A. Let's do sine of A. Now sine of A is opposite over hypotenuse. So 21 over 29. Ah, check, right? So that's good. 20 over 29. Now let's do tangent of A. Tangent A is opposite over adjacent. So we got opposite 21 over adjacent 20. Oh, that's not the same thing. So no. Now let's do the ones with B. So now this is going to be B. So I'm going to erase these so you don't get confused. So what's the opposite of B? So the opposite of B is 20. And then this is still the longest side. The hypotenuse is always the longest, so that's not going to change. And then this has to be adjacent by default. All right. So let me erase this line so we can just focus on B. All right. So we got cosine of B is adjacent over hypotenuse. Now adjacent is now 21. So adjacent over hypotenuse is 29. Oh, that matches up with that. So we got this one. So this looks good so far. Now let's look at sine of b. So sine of b is opposite over hypotenuse. So we got opposite is 20, hypotenuse is 29. Oh, can't be that one. And then we got tangent of b is opposite over adjacent. So 20 over 21. Oh, can't be that. It has to be 21 over 29. So answers are B and C, okay? All right, so in triangle ABC, BC is equal to 15 and is the longest side of the triangle. Okay, so let's draw that out. So we got a right triangle, and it's called ABC, and BC is the longest. Okay, so ABC, and they said BC is the longest side. So this is the longest side, and this is 15. That's what they said. And so, and that's all we know. Now we can use the Pythagorean theorem here. So we got AB squared. Remember, it's A squared plus B squared equals C squared, right? So A squared plus B squared. AB squared is AC. Is equal to C squared, the BC squared. Now BC squared is 15 squared, so I'm going to use that, okay? And 15 times 15 is 225. Now, if it's equal to 225, remember it's a right triangle. If AB squared plus AC squared is less than 225, recall that I told you that that would be an obtuse. And if this is greater than 225, then that's an acute. Okay, so you just got to know that. All right, so it says if AB squared plus AC squared is greater than 225, then that means it's, well, what did we say? It was acute, right? If it's less than 225, what did we say? It would be obtuse. So it's just a matter of knowing that. All right, so Eric is standing 120 feet from the base of a tree. She is looking up to the top at an angle of 30 degrees. If her eye level is 5 feet, how tall is the tree? Okay. All right, so we got 5 feet tall, and we got 120 feet there. From there to there is 120 feet, and then we got a 30-degree angle. Okay, so let's look at, so it says we want to find how tall the tree is. So let's call this here X, and let's call the height of the tree H, okay? Now, the person is 5 feet tall, so H is going to be equal to whatever I get for X, which I'll do that in red, plus the 5 feet, the person's height. Okay, plus 5. That's how I get my H. Now I need to get X, so we're going to use this right triangle for that, of course. So now we're going to use trig. Remember, SOHCAHTOA, right? So how do I know I use trig? It's because I'm dealing with a right triangle, right? And I don't know any, and I'm trying to figure out one side, and I'm given an angle, and I'm given only one side, right? I'm given one side and one angle. That screams SOHCAHTOA, or not even SOHCAHTOA. You could use SOHCAHTOA, or notice that it's a special right triangle, 30 degrees. So it's a 30, 60, 90 triangle. We just talked about that not too long ago in the formula sheet. Remember those couple problems? So we got a 30, 60, 90. So that should immediately tell you, okay, 30, 60, 90, special right triangle. So let's draw that, but let's make it look like this, okay? So let me do that. So let me draw this right triangle here so that it's 30, 60. Now, between the 30 and the 90, is X squared root of 3, okay? So we got to draw it like that. X square root of 3. Now again, they use X, and we already called that X. So I don't want to confuse that. So I'm going to use a different letter, all right? A square root of 3. Now this between the 60 and the 90 is X in the formula sheet, but I'm going to call it A. And between the 60 and the 30 is 2x, but we don't want to confuse that. So I'm going to call it a, so 2a. All right, now we're going to compare these. We can see that x matches up with a. So we get x is equal to a. We can also see that 120 matches up with a square root of 3. And that's what we want to do. All right, so 120. So I'm going to say a square root of 3 equals 120, the two blues. Now we got to solve for a. So let's divide by square root of 3. That cancels. And so we get a is equal to this, right? But we do not want the square root on the bottom. So I'm going to multiply both sides, top and bottom, by square root of 3. So we get 120 square root of 3. Now remember, this is equal to square root of 9, but the square root of 9 is equal to 3, right? So we're going to plug that into there. All right, now 120 divided by 3 is 40. So we get 40 square root 3. So this is what a is equal to. A is equal to that. All right, now if a is equal to that, then I can plug that in for x. And so x is equal to 40 square root of 3. So now we know what x is. Okay, so we can plug it into the height. So the height is equal to 40 square root of 3 plus 5. All right. Okay, good. So that's good. So they looks like the answer. So which one is it? 120 divided by 3 is 40. So that looks like 40 square root of 3 plus 5. Yeah, so it looks like 40 square root of 3 plus 5. They, for some reason, didn't divide 120 by 30, which is 40. So yeah, but either way, that's the answer. So, because 120 divided by 30 by 3 is 40. But that's what we got, 120 square root of 3 right here. And then we add that to 5, okay? So there you go, there's your answer. So let's, we're gonna pick that. So the answer has to be B. All right, so now it says support wire for an electric pole makes a 60-degree angle with the ground. So this is the ground here, and a 60-degree angle with the ground. If the bottom of the support wire is 10 feet from the base of the pole, so we got 10 feet from the base of the pole, which of the following equations can be used to find the length of the support wire? So let's call the length of the support wire x, okay? Length. All right, so let me do that here. I'm just gonna call this x. All right, so how do we do that? Well, we're gonna use SOHCAHTOA here because they have cosine and sine and tangent. So we're not gonna use a 30, 60, 90 triangle, even though it is a 30, 60, 90 triangle. We're gonna use SOHCAHTOA for this part because of the multiple choice. So SOHCAHTOA. All right, so then, yeah, so let's do that here. So SOHCAHTOA. And then, okay, so now, this is a 60-degree angle. This is opposite. This is hypotenuse. And this is adjacent by default. So which equation do we have? Well, we don't have opposite, so we can ignore that. I'm going to ignore that now. We do have adjacent and hypotenuse, right? We have the 10 feet and we have x. So which one has 10 and x? Well, which one has a and h? Well, that's got to be cosine, right? C for cosine, for AH. So we have cosine of 60 degrees, you always have to provide an angle, is equal to A, which is 10, over x, which is h. There you go. There's my equation. That's the best one because it has those two sides that we were just looking for. All right, so now we can solve for x here. So the best way, if x is on the bottom, just switch this with that, okay? So we're going to put x on the left side and cosine of 60 on the bottom. So we're going to switch the positions. So let me actually do it this way. So I'm going to switch the positions. So we get x is equal to 10 over cosine of 60. There you go. That's the easiest way. Just switch those two positions, and then you have x on the left side. That only works if x is on the bottom, and then you can just switch it like that. All right, so we got 10 divided by cosine of 60. Is that it? And even then, they didn't want you to solve it. See, look, they didn't want you to solve it there. They just wanted you to set this up, it looks like, I think. So let's just use that. So cosine of 60 equals 10 over x. Cosine of 60 equals 10 over x. There you go. So they didn't even want you to solve it. They just wanted the equation. All right, so it's got to be B. Now the next one, the Eiffel Tower in Paris, France is 324 meters tall. So we got a tower that is 324 meters tall. If Maria is standing 200 meters from the base of the tower, so this is Maria, 200 meters from the base of the tower, there to there. What is the angle of elevation from the point where Maria is standing to the top? So angle of elevation. Angle of elevation means you're here, she's here, and she's looking straight ahead, but then she has to stare up at the tower, right? That's elevation. Elevate means up. If she were on here, and then this is her line of sight, and then she's looking down at something, then that would be depression, angle of depression. Okay, DEP for depression, and then so we'll just do that. All right, so depression. All right, so all right, but we're doing elevation, so that we're going to call this angle theta. We're going to use the Greek letter theta. Okay, that's just a letter. That's just a variable. All right, so let's look for that. Now, which trig function do we have? Opposite, and we have, this is hypotenuse, but we don't have that, so I'm going to ignore that. So then this is adjacent. So use SOHCAHTOA. We got SOHCAHTOA. Which one of those do we have? Opposite, adjacent. This one right here. So it's got to be tangent, TOA. So tangent of that angle, that variable, is equal to opposite over adjacent is 200. There you go. Now let's solve for the angle. That's what they wanted, the angle, right? So how do we get rid of tangent? We have to do the inverse tangent. Remember, you have to do the inverse trig. That's going to cancel out. Whatever I do on the one side, I got to do on the other side. So we get theta equals inverse tangent 324 out of 200. I'm going to do this on the calculator, round it to the nearest tenth. All right, so let's go ahead and do that. So we're going to do inverse tan. Then we got to do 324 divided by 200. Just do division for fraction. Then I'm going to do parentheses, but there's your answer, 58.3 degrees. All right, so this is 58.3 degrees to the nearest tenth. Okay, remember, nearest tenth means like the dime position, or the dime position. The nearest hundredth is like the penny position, right? So you just got to know the difference between those. All right, so storms. During a storm, a tree breaks 4 feet above the ground and falls to form a right triangle. So you got a tree like that, and then it breaks, and so this part ends up falling down, right? That part of the tree falls down, and so you get something that looks like a right triangle. And I'm going to do dot, 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 dot. This is like the original tree, if you will. That's the original tree. But now the tree is down here. Okay, so you can see that, this is the ground. And it says the top of the tree rests 11 feet from the base of the tree. And then it says the tree breaks 4 feet above the ground. So this is 4 feet above the ground. And so we need to figure out how long that part is. And then it says approximately how tall was the tree. So the answer is going to be whatever x is plus 4. So let me do this in red. So we'll call this x. So let's see if we can find x. And then x plus 4, that's going to give us what we want, right? That's going to be the original height. Is x plus 4. All right, so let's go ahead and do that. Let's use Pythagorean theorem. Remember, it's a squared plus b squared equals c squared, right? So we got a squared plus b squared equals c squared. And remember, we're going to try to solve for x here. So in order to solve for x, we got to take the square root of both sides so that this cancels. And that'll help us solve for x. So x is equal to square root. 4 times 4 is 16. 11 times 11 is 121. So this is square root of 137. All right, and so the original height is square root of 137 plus 4. Now you just got to do that on the calculator, and we're going to round it to the nearest tenth, okay? So square root of 137 plus 4. All right, so let's do that here. So we got square root of 137, and then we got to use this right arrow key, and then plus 4. Remember, the 4 has to be on the outside. It can't be on the inside. So we get about 15.7, okay? All right, so this is about 15.7 feet, approximately. All right, so there you go. That's going to do it for the video, guys. Hope you found this useful and informative, and as usual, I'll see you in the next one.